In the previous video, we learnt how to put Perlin noise across multiple terrains using the world position to calculate heights from. Now we have this really interesting little problem where they don't still seem to be matching together, but this is a different problem to what we had before. Now, let me first of all show you what I came up with. So I wanted to figure out why these values here in world position, or any position, weren't calculating the same heights, because this value here should be the same height as this value here. So it made me wonder, well, does the Perlin noise algorithm think that the value from here that I'm giving it is this pretty much the same as this value here? So the way I did it was actually to go back into my code and put some hard-coded heights in. So at this point, before we set the heights, if we go like height map, and let's say we go 20, 20. So at 20, 20 in our height map, we're going to say equals 1, like that. Okay, so let's give us a high sort of spike at 2020. So let's save that and go back into Unity and have a look at where we get those spikes. So we're getting a spike here. So this spike here, this is obviously like 20 and 20 in the height map, and you can see that each of the others also get it at 2020. So that looks pretty much right. Okay, so the 0, 0 positions of all of these terrains is this particular corner here, because that's 2020 there. So that's fine. Let's now go back into that code. Instead of 2020, let's make it like 20, and I'm going to say 200, like that. So we can actually see a difference between the X and the Z value. So let's save it and switch back into Unity. So the position for 2200 you would expect to be 20 in the X direction and 200 in the Z direction. But have a look at what you get here. So this is obviously in 20 and across by 200, but the orientation of the direction of these particular height maps, if you have a look at your gimbal up in the top here, the X direction is actually running like this. So we've told it to put this spike at 200 in the Z, but in the world, we're actually getting it at the X direction. Therefore, that made me conclude that the values in the height map are actually orientated in the other direction to what the X and the Z of the world is. Okay, so why Unity puts terrains by default like that, I do not know. But we have encountered this issue in previous versions of the course where height map data was actually the other way around. So in this case, we have to swap the Z and the X value like that to switch it around. Now we don't need this height map setting anymore. Let's get rid of that. Now, just before we continue, I just want to make a little bit of a change in here and put the terrain data into its own variable, not for any particular reason other than it just makes things a little bit neater. So this will be terrain data like that, and then you can just use terrain data throughout here just by removing wherever you can see it and accessing terrain data directly like that there. Now the other thing is I'm going to also put a float in here so that this calculation is float divided by float, because as you've already seen, getting these heights correct, because we're transitioning from ints to floats and all over the place, sometimes we lose a little bit of thing in the mathematics. So I'm just going to make those little changes. So save that, switch back into Unity, and once it reloads, you'll see that it's still not quite right. Now, what is happening to this? Well, this next problem is that we are still considering the values of the height map resolution and the actual terrain size still relative to the actual terrain that we've got. So if you have a look at your terrains, and let's just go from this sort of angle here, you can see on this terrain here with this bump, it's the same as that bump there. So the Perler noise is still happening the same on each surface, even though it is orientated in the correct way. So what we need to do with our Perler noise values is we also need to offset them by the actual terrain's position so that they're not all starting from 0, 0. Okay, so that's quite a simple fix. Let's go back into our code, and to these values that we're calculating down here for the world position, we're going to also offset it by the terrain position. Okay, so it'll be terrain dot transform dot position dot x for that one there, and plus terrain dot transform dot position dot z for that. Now those values will then translate into the proper world values. Let's save it, switch back into Unity, and we'll have another go. Alright, so there you can see that that is now correct. While we're here, is if you're experimenting with these terrains, and this has actually happened to me while I was putting this together, is that sometimes no matter what you do, these values don't seem to change. Now you can generate these terrains using code and then hook them up. The only problem I've found is that the whole system gets very much out of whack, out of sync. So if you do find that what you're trying to do just isn't working and makes no sense at all, you might consider deleting all of the neighbors and then just starting again by putting them in manually by clicking in here rather than trying to generate them. Alright, so we've got that. Let's have a little bit of a sneaky look around this landscape, because the values are going from floats to ints to floats and those sorts of things. What you'll get, and this is actually not a bad example of the height map, but kind of meets quite nicely, but depending on the Perler noise that you use, you can find that you'll get seams appear, and there's a very, very small crack that you can see just in there. Unless you overlap these terrains, then you're never going to get rid of that problem. But what you can do is actually work with the values on the edge to get them to be the same as the terrain that they're about to connect to. So if we just go back into our terrain control, I'll just see if I can make some sort of edge values here that might make those seams appear a little harsher. It's actually quite difficult in that sort of landscape to find a seam. Let's bring this down to 1 on there as well, and reduce the height down to 0.1. Okay, it's going to make a liar out of me what I'm trying to show you, but you can get slight seams in here that you might want to actually fix. I mean, I can see the seam just over here on the edge. Okay, so what we're going to do in that particular case is to add some extra code, and we'll come back and do that in the next lecture.